This meeting is being recorded.
In this video from Chapter 15 on chemical equilibrium, we're going to take a look at sample exercise 2 from the Chapter 15 worksheet. And in this question, we're given some information. We're told if the equilibrium concentration of CO2 is 5.0 molar. The equilibrium concentration of COCl2 is the same concentration again, 5.0 molar. At 395 C. We want to know what the equilibrium concentration of CO is in this reaction. So that's what we're looking for here. So we know that both concentrations, right, we're given CO2 equals the equilibrium concentration of COCl2 gas, and that's equal to 5.0 molar. We're also given the Kc value here at that same temperature. So the only reason that we're given the temperature here is to note that both our concentration and our Kc values are given at the same temperature, so we can use them interchangeably. So in step 1 here, first we're going to set up our KEQ expression here, our equilibrium expression. And that would look something like this, where we have K equal to the concentration of our products. So that would be COCl2 over our reactants. And if these had stoichiometric coefficients, we would make sure to indicate them. But all these reagents, reactants, and products, they all have a coefficient of 1. So this will be our equilibrium expression here. We're going to set this equal to the values that were given in the problem above. So we're going to have 5.0 molar on top. We'll have CO concentration on the bottom. That'll be our X. That's what we're solving for. And then we have 5.0 here as well. And we're going to set all this equal to our K value that we're given. So we're going to set this equal to Kc, which is 1.2 times 10 to the third. All right, so now we may notice that if you're good with algebra here, that these values will actually cancel out. So we can rearrange this equation and actually simplify it first to be 1 over x, right? That's the only thing on the denominator now, and the numerator turned into a 1 equals 1.2 times 10 to the third. And now if we rearrange this, so really we're just going to swap these two values. We'll multiply both sides by x and then divide by 1.2 times 10 to the third on both sides. We get this rearranged expression over here. 1 over 1.2 times 10 to the third will equal our x. And we can plug this into our calculator and find that x will be equal to approximately 8.3 times 10 to the negative 4th molar. If you're given, instead of concentration, if you're given pressure values, you can also do this type of problem and just utilize Kp instead of Kc.